How about now? Is there audio now? I think it only live streams track 1 of the audio. More? Working? Paul says yes. Colin says yes. Yep, let's go. So, yes. I'm going to try and tear this thing down. It was a mission just to get it to the desk. This thing does weigh about 40 kilos, give or take. I think it's 35 to 40. I've not weighed it, but it's like it's the only thing that makes me think my desk might not manage it. I barely managed to lift it, and because it's like a really awkward triangle shape with all rounded edges, it's really difficult to grip. So today we're going to tear it down to pieces and find out why it weighs 40 kilos. The other thing we're going to do, we have many camera angles. I'm going to try and remember to switch between them. I think look at the latency. Anywho, whatever. It is what it is. Hopefully I'll try and remember to switch between them as we go. We've got a few different angles to hopefully help show all the different things close up. I can't even pull my arms all the way around it. What if I stand up? I'm slightly taller than it when I stand up. It looks extra big on camera. I'm taller than it, so it is a little bit in front of me. But yes, it gives you some perspective on how enormous this is and why everyone had so much trouble getting it into their studios. I need some tools. Where are they? 2, 3, 2.5. That probably do now. Get some of these out. This isn't going to be instructional particularly. If you see my other live streams of teardowns, that will give you some idea of what my plan is. I just want to tear it down. Take out all the screws until there are no screws left. Try not to break anything, and then I'll put it back together either in another live stream or just on my own. The idea is not to break it in any way. It's just to basically have a look at all the stuff that's inside, because a lot of the time you don't get to see it. I mean, even this door, this is a glass door, so it's pretty heavy. Some weight off. Let's take off the upper door. Hopefully I don't drop anything in the process. The last thing we want to do is break these glass doors. Oh, well, that's one screw run away already. Right, get that in there. There's that screw. It's been a little while since I've done a teardown, and they were quite popular previously, so people kept asking me when am I going to do another one. So here I am at a random time on a Monday morning doing a teardown that no one will be able to catch because they're either asleep in America or at work in the UK. But there you go. This is how I roll. I felt like doing it. I was actually going to do it yesterday, and then I had something else I wanted to do instead. So I figured, because it was the weekend, I would not do work things. I think panels first. I'm going to try and rotate it. It's all right. That was the stuff inside. Hopefully by disassembling and a sort of, oh, this looks a bit mangled. In a sensible way, I'll be able to get it all back together without damaging anything. This looks like it's actually, oh yeah, this one's, some of them are reset, some of them are not. Whoop. I could have put on one of my new t-shirts. I'm doing a bit of a investigation on t-shirts at the moment, which might not sound very exciting, but I think it's quite interesting. Because basically, when you buy t-shirts, oh god, nobody's going to be interested in this, are they? Don't leave. I don't always talk about t-shirts. Basically, you just get some really rubbish ones that are all like crispy. And some of them are really soft. And even within like a single brand and a single style, they'll still be made of different stuff and not be consistent. So I bought a bunch of t-shirts to find out which ones are soft and nice. And then we'll work on some fancy designs. And then we'll have some nice t-shirts that everyone can get. I want to do some kind of community competition, or so we end up with a community design. I'm not necessarily interested in it being a Vector 3D design or having logos on or anything. Just some fun 3D printing t-shirts. Right, that panel is all the outside screws off, but I suspect there will be more screws on the inside. Give it another spin. I could have put this on a Lazy Susan, but it was a bit of a risk because trying to put something on a Lazy Susan, if you don't get it right in the middle, like you end up like spinning it and it slips away. And when something weighs nearly 40 kilos, I didn't want to risk losing control of it. Ooh. You know what would be really helpful? I've just had this idea. Magnetic top surface for a desk. Because every time I drop a screw, it would then just go and stick to the desk. Who else wants a magnetic top? How cool would that be? I mean, it obviously wouldn't work for stainless steel screws, but that would be pretty handy for all the time that I've dropped small things. I also have no idea how long this is going to take today. It will go on as long as it needs to go on. I think we're having the postie collect some stuff. Oh no, that's tomorrow. So I think we're pretty free until like 2 o'clock, 3 o'clock. I've had my stroopwafels and banana to keep me going. Hopefully we can power on through. What I'll just do is open the window a bit more, get some breeze. It's quite warm. And now I'm handling this, it's even warmer. Ah, yes, a nice breeze. You can probably hear the seagulls. It is very noisy seagull time of year. Right. That's obviously for the fan. It'll be fine. I can't really see up in there. Need a... Yes, just a bigger one. So there's some reinforcing steel bars. What the fuck is that? There's some reinforcing steel bars that the handles screw into. So the handles don't just connect to the panels, but hopefully kind of through to the main stronger part of the frame. Connects to the main frame. I'm doing this in a way that you can't see. So that's a handle. Oh, steel handle covers. And then that's just like the backer, which your fingers go into when you hold it. And that's the panel off. Folded sheet steel panel. I mean, that weighs quite a bit just on its own. Quite well made though, I'll be honest. Which has been a bit of a theme, I think, from my perspective so far of this machine. Good hardware, rubbish software. So I'm now thinking how we get this off, because there's screws on the outside and there's screws on the inside. That connects to that. Oh, I think these outside ones. Oh, wrong screw. I think this might just be a panel so you can replace the filter. Because I think there's a little like HEPA sort of filter. If I remember correctly, HEPA just stands for High Efficiency Particulate Air Filter. There you go. That's the little boxy boy. Not sure if anyone's actually opened that panel before. So I can hear carbony pellets. There's a filter thing that side. So, I mean, I don't know functionally how well it actually works. I've not tested the efficiency of this filter. But in theory, fairly sensible. And then that's the actual fan, which is secured from the inside. I'm going to need some way to store these parts. It's going to be a lot of stuff coming off this printer. You need a headlamp. I was thinking, I've seen somebody else recently, I can't remember. One of those, oh, what's his name? RC something? Hello, Steve, good to see you. That has like a head camera. I think that would be quite interesting. I think it would be a little bit... RC Test Flight, I think that's the one, yes. They've been doing live stream assembly with the head cam. I've not seen the live stream, I just saw it in a recent video. What time is it where you asked? Aren't you like 7 hours different? Yeah, we need constant spinning. Spin me right round. Yeah, I don't want to take the handle off yet. Shh. It's so loud. Wow, this, look at the thickness of that base. Holy bananas. Jesus. No wonder it weighs 40 kilos. Crap. Right. I'm not sure how I'm supposed to unplug that, because I can't actually get to it. That shall just dingle dangle for now. RC Life on. RC on Life. It's somebody like that. 4 AM. Couldn't sleep. Well, at least you get to watch me make a hash of this instead. These caps that they've put on this, I do not understand. It's just like some sort of... I don't think it's meant for this purpose. It's like the screws are too long. So they've put in this kind of crushable spacer. Ooh, camber change. Focus, focus. Not much light over here. It's really odd. Like, it's hollow on the back. So when you put a screw through, it just gets absolutely crushed. A little bit weird. Right, that goes down there. That's another handle. Then we take this side panel off. Oh, switch camera. Back to... Ta-da! Yes, this is another panel. Oh, which one was I on? Was it that one? I have no idea. These panels alone probably weigh a kilo. This is like a PTFE pass-through tube nipple thing. What does it weigh now? A lot. I think it is just, I mean, the frame itself, I think, just weighs 20 kilos. I think the next thing we need to actually get to is in the top. So, check this out. You ready for this? Ta-da! Oh. Such flexibility. You can't see in the top, but you can get an idea of what I'm doing, I suppose. Maybe I'll tilt it down. That might be a better idea, and then I don't have to stand up here precariously on a chair. Correct, this one is falling out. I had a cowboy, as we call it. That's probably a bit of an offensive term nowadays, actually, isn't it? Basically, a workman who was not very skilled or was very careless came and changed the lighting from the like 12 volts converted variety to 240 volt mains, pulled all the light fixtures out, but damaged the whole ceiling in the process. And now they just start falling out, and you get all this plasterboard stuff falling down, and yeah, it's just a bit of a mess. Right. Again, that's steel and that weighs an absolute boatload. I'm going to get some scales because I want to actually weigh some of this stuff because it's actually insane. If I can find some scales. What do these go up to? Only up to 3 kgs. I don't think I have any good scales at the moment, so we might have to make do with something. Just this top cover panel. 1.2 kilos. That's like... Oh, you don't really need to see it under the desk. Just for a top cover panel. 1.2 kilos. It's absolute. It's just insane. Let's see how much this weighs. 1.9 kilos. So basically 2, 2, 4, 5 and a bit. That's another kilo. 6 and a bit. That's 1.6 kilos. So what, 7 and a bit, maybe 8, nearly 8 kilos? Just with some cover panel? 1,200 grams. Yes, 1.2 kilos. Nearly 8 kilos of those, just those parts I've taken off so far. 2 side panels, 2 doors, and the top. Right. Ooh. Oh yes, that's a silicon sock I meant to replace, but haven't. The question is, oh yes, the top. Let's need to try and take this fan out safely. Trouble is, I'm still concerned about. Once I tip it over, I'm not going to be able to untip it. Oh, I suppose what I can do, I'll just unplug this fan so we can continue with what we were doing. There we go. That's the van. I'm just going to take a picture of what we have up here. Just in case I have any trouble putting it back together. Normally don't, but it's worth trying to be sensible. These top and bottom pieces are like huge pieces of die cast metal. The spool shouldn't fall out, but you're right, it's probably wise to remove. Let's just give this a snip. This is the other filter thing. This is, well, no, not filter, desiccant. Because this is like a heated dryer. I'm not sure anyone's tested, well, I've not seen tests of how efficient or effective it is, but technically it is a heater dryer thing. Let's take this out. I'm sort of hoping this will come out as a unit, but I could be very wrong. I don't know how this is going to go through that hole. It looks like they've pressed it. Oh no. Is that? There's two holes. I think there might be a... That's not going to be easy to get into. There's some soft stuff around the edge that's sort of holding it on a bit. I think there's other stuff holding it in. Aha! Screws for this roller. Let's see if you can... We change to this one. Is it what? Yeah, that. So the spool holder itself is attached to a load cell, which is a strain gauge attached to a piece of metal that bends in a controlled way, and that basically measures the weight of the spool holder. Unfortunately, from what I've seen and used, there's no way to calibrate it. So if you have a heavier spool, it doesn't actually know that the spool could weigh 400 grams. So it doesn't give you really a very good indication of remaining weight. I mean, even this spool holder is very overbuilt. Let me show you. Yeah, there's not much light in this direction, unfortunately. But like this thing, let's get the scales so you have an impression of what it weighs. It's got like bearings and stuff inside for sure. 80 grams. So first you got this like rubber gasket thing, and that's to help seal the enclosure. And then it looks like it's like a split design, which should open to see some sort of bearing and shaft arrangement or something. I think I'll assemble this directly back to this. I don't want to leave it unassembled. Yep, there you go. This big shaft with these two bearings. This is plastic, but still. Kind of bonkers. Heat set inserts. Heat set inserts. It's just great. On the basis that you can't calibrate it, I mean, technically it's probably sensitive enough, but with cheap controllers, you get a lot of noise. So the accuracy is probably not fantastic. So like sub-gram, you're just not going to be great. I always forget which camera does what. Right. I don't think this is anything special. Apart from the fact it's a 36-volt fan. What? Is it a 36-volt printer? I don't know. It could be that they're running it at 24 volts. But this is a 36-volt, 0.2 amp FLsun DC brushless fan. Ta-da. Very dark, sorry. Next, let's get this filament out of the way. Yes, spool holder. Spoolie, spoolie, spool. Oh, I can't really see. So we've got this, the feed tube, PTFE feed tube sticks down that hole, and that was getting a bit stuck. We also got filament sensor, which is attached to this part here, and the load cell sensor, which for some reason goes over there. What the absolute dickens. There's like another control board over here. And everything be glued in. Gosh darn it. What's that? That's just a rubber stop, I think. To get the load cell out. I think we've got to stand up the top. This one here. Ow! Need a ball end 3mm. 3 ball end, yes. Oh. That should release the cover. For the load cell. Still fully attached for some reason. How's it holding on? I do not understand. Eh? I wonder if it's glued. Okay, let's unstick that. That'll get it out. Holy bananas. Right. Let's have a closer look at this. So obviously this is the place where you put the spool in. Then it looks like ventilation, that's a sensor. That looks like the sensor for humidity, because that's where the tray goes for the drier desiccant stuff. Obviously this is just here for thermal insulation to try and keep it warm. We've got a control board thing up here. This is where the load cell was plugged in. Got loads of goopy goop on it. I need to try and take it off, otherwise I won't be able to get it back in probably. So yeah, that's a whole control board just for... How did I pull that off? Okay, well that's come out as well. It's actually insane. I'm not sure what's under here, so I think we need to find out. Oh. Wires with connectors. Where do they go? It must be fans. Well, it doesn't have to be, but I'm assuming it's some fans. Maybe this is one hole pattern for fan. Maybe we have to tear this apart more. Let's get a quick reading on what it weighs. The hardware is good, the software is rubbish. This is basically another 1.3 kilos, 1.27. Because this whole front panel is steel. I'm assuming for them steel is cheaper than aluminium. In general it is, so that would make sense. You could probably save 30% of the weight by making it out of aluminium. We've also actually not seen where the heater element is yet, so we also need to find that as well. Maybe there isn't a heater element. I thought it was a heated chamber. It might just be that it takes in the air from the printer and uses that. In which case, I'm not sure why you would insulate it, because you're insulating the wrong way. This cable around the bottom is the filament sensor, which is still attached to the printer. So hopefully we should now be able to detach this. Ta-da! Aha! I think that metal plate is the printer. This is the jankiest thing I've ever seen. Holy bananas, Batman. Okay. So what I think, this here is a blower fan that blows air across here, and this plate is the heater. There's this 3D printed part that I think is holding this in, but I think it might be glued. I think this originally, this whole pattern, I think was for a fan, and I think they changed their mind about how it would work, because it looks like this bit here, you see this slot? I think this would be 40mm high and would fit a 40mm fan when you slide it in, but they realized they don't want to take temperature from here, they want to recirculate. So Thing is, I don't know how to get this out. It's on this 3D printed bracket here, which again suggests that they changed their mind and had to create a new solution. Is there screws under this? Yes. Sneaky, sneaky. That's why there was some suspicious insulation. Which clearly does absolutely nothing. So it's a 36 volt, 48 watt PCB heater. No heat fin array or anything. Just a PCB, what gets warm. Doesn't seem particularly safe, does it? Considering there's no thermistor or anything. Don't know how hot it gets, but presumably that on 36 volts can get reasonably warm. Blimey. Okay. This has got to be glued in. Can you see it? Sort of here. So that's the fan. This is part of the 3D printed bracket, and this is part of the 3D printed bracket right at the bottom. The screw is going in that direction, so there's no way I can get to the head of the screw. It's too sharp an angle. I tried pulling this because there's like a little handle. Oh, there we go. Bit of wiggle. It's stuck in with stickers. Tapers. Yes, this is 100% how it used to work. Oh my god, look how janky it is. It's held in with one screw. Wow, such design. So jank. Oh my god. What the fuck? Oh. Hopefully we can zoom in a bit and see this in its full glory. I don't know how much of it's digital zoom, like cropping, and how much of it's optical zoom. But that is something special. The wire's just sort of jammed under it. It's the same kind of fan they use on the Clarity Ender 3s, I think, isn't it? That's one of their blower type fans. That's, well, it doesn't belong to them, I don't mean, but it's just a 40mm blower fan. And then there's the weirdo bracket that they had. Ah, maybe. I think so. Let's get this out. It's our PCB heater. So safe. Looks like to me what they used to have is this. Because that perfectly matches the hole in the bottom here, which in the latest version doesn't do anything. It lines up to the 40mm holes here. In fact, no, it wouldn't do. So what they used to have is it pulling air across here from the ducted thing and blowing it into here. And they changed it around to go that direction to pull in. It just doesn't really do anything because it doesn't pull properly because there's no duct. It just sort of blows across here and recirculates in the same little area. I'm not sure how well this will work. Not really tried it, to be honest, because the user interface is rubbish. It doesn't really give you any options. But there's this whole PCB, this whole unit. Oh, blimey. Okay. Let's just pretend this doesn't exist. Goodbye. I'm just going to run out of space very quickly. I don't think the heat would melt the fan. I think the heat, there was probably not enough circulation across the heater. I don't know why they've got the vents in the middle. That's the bit that's a bit confusing. Maybe they've added these. Because if you didn't have these, and this was down here where it used to be, then any air that's pulling, and therefore anything that's blowing, is coming across that heater. But the addition of the vents means that it's going to end up sucking from here rather than over here. And I mean, having the fan the other way around just seems like a very strange decision. I mean, it doesn't really. What probably would have been wiser is having the fan like here and having the normal 40mm non-blower type fan. So it pulls in from there and pushes across here, and then you can like prevent anything going across. Maybe not enough pressure. Maybe the cost of having two fans or something. I don't know. Do the vents cool the backside of the PCB? No, nothing cools the backside of the PCB. The backside of the PCB is only heated. Interesting, hey? Oh, I think we'll just have the little trays for now. Love these frickin' trays. Oh dear, oh dear, oh dear. Right, time for a quick drink. I mean, bear in mind that the fan will probably be on the whole time the heater is on. They're probably even on the same circuit. If the fan fails, you've got a big problem, and you wouldn't know because there's no RPM sensor. So then you would have quite a bit of heat. 50 watts is not that much, maybe spread over that area. It's quite a large area. But it could probably reach 100 degrees without too much trouble, I guess. It's a little bit worrying, isn't it? Right. Which bit do we take off next? Let's do this. This you have to install as part of the initial assembly. Oh, was there screws? No, they go in from the front. Yeah. So when you get the printer, you have to install this LCD screen, which on its own also has huge, great, whopping PCB in it. That's interesting. is a different size. There we go. So here, you probably maybe can't see super well. What about this top one? Number 2. Yeah, you see here, there's 3 USB-C cables, and then there's 1 ribbon cable thing. So 1, 2, 3, that are all numbered. So that's what you get there. Yeah, these you have to install as you get it. This weighs 800 grams for an LCD display and a button. Should we take apart this now, or should we take this to it now? I was going to say now or in a minute, but I think now, and then we can move on. What the hell? One of my cameras is beeping red at me for some reason. It's probably overheating or something ridiculous, is it? It's this one here. You can see my legs under the desk. I don't know what it's got a problem with. It's just beeping red. They do get rather warm, these things, for little cameras. Lens communication failed. What? Let's see if we can turn it off and turn it back on again. Select device. We should go back to that in a minute. Oop, what was that? Oh, that's just broken. Amazing. So, what we have in here, so this one is USB-C, USB-C, and a power button with LEDs. This one is the color bar, which everyone has only ever seen in one color, apart from like one person who made it go another color somehow and then never saw it again. It's got hundreds resistors on the back for some reason. And then you've got these two ribbon cables, which come from the LCD display on the front, which is in the middle here. And that connects up to this main board, which has some buttons, the connectors, some power conversion, whatever this does, in a pretty pattern for some reason. Is there an MCU on there? Oh, there's stuff on the other side. Let's open it more. This is obviously Wi-Fi or Bluetooth. Where's my two? It's gone. I think all the important stuff is in the top here. Try not to break the ribbon cables. This is red Loctite, I think. Which is a blooming stupid thing to do because that's glued there and then it's glued there. Oh, I've got to be careful. I'm not trying to hide it from you, I'm just trying to get it at an angle where I can safely and carefully unplug things. So for the ribbon cable, there's a little black lever. You have to pop that up, and then the cable comes out. Ooh, the other ribbon cable goes to a tiny little connector. That one, so there's a black part at the edge of the BCB. You have to push that back towards the edge. And then that'll lift up. So that's two ribbon cables off. I hope I should be able to remove these a little bit easier. Right, now we can get to this. So that's a rock chip, and these are memory chips. This might be, this is like the RAM, and I think this might be EEPROM or something. Not EEPROM. Oh, I've got the name of it. eMMC. So like a permanent storage. That's my guess, but I'm not 100% sure. But this bit here to me looks like it's basically the Raspberry Pi part. Your single board computer, because that's what the rock chip thing is. Which makes sense to have it by the LCD display, so, and that justifies having the Wi-Fi and stuff right here. Of course, you want the Wi-Fi outside the frame, so that's kind of also why it's there. Boot buttons. This is probably a diagnostic header or something. Interesting, eh? And that's where your connectors then come out the back. Does the camera quality look bad from your perspective? I can't really tell on my monitor what it looks like. I mean, yeah, they were RAM, yeah. That's like my main camera. That's clearer, but it's miles away, so you can't really see much. That's the back, really, of the PCB anyway, isn't it? Right, we'll stick this away. That's a problem for future Adam. On to the next part. Maybe take this front panel off. Ooh. No. I thought it was plastic for a minute because it made a weird sound, but I thought again. It is metal. Absolute. It's just insane the weight they've put on this thing. This single piece. 420 grams. Just for this single little panel. 420 grams. It must be getting to a point where I can lift it soon because we've taken how much off? 10 plus kilos? The next thing we might be able to take out, if this will stay up, it sort of stays up at the top, is the heated bed. Because this should have a good bit of weight to it as well. Hello, Science Sniper. Looks good to me. The close-up cam and the main cam are warmer than the other cam that was overheating. Yeah, I mean, the ones that I can control directionally, I can't really fix the colouring of very easily. Whereas my main camera is adaptable. But I'm also using a mix of actual daylight and LED lighting here, so the colouring is a little bit of a mess. So this is your standard spring steel. It's only single-sided PEI sheet. This should just sort of lift out. Oh, no, it's going to lift out separately. This is going to be weird. Okay, that comes out. That's not what I expected. Okay. On the back here, they have what I presume to be like a calibration thing. Yeah, this camera is really cold, isn't it? Everything looks kind of weirdly blue. Yeah, you can see this like inspection pattern. Sort of. Maybe if I get it close, you can actually see it. But I've never once seen the printer actually look at it. So, I'm not sure what it's there for. But it doesn't seem to do much. Holy bananas. This printer's mental. Right. This is just like weird floating bed in the middle. It's a solid mount, that's for sure. Now, I think we have to take out all these screws around the side. One. No, do DJI do remote control cameras? They're, I made a video on them, but it was not very popular. They're OBSBot cameras. I've forgotten the name of them now. That's not good, is it? Tail Air. They looked quite reasonable in terms of what by specification. No, back up there. Up you go. I can see the power supply from here, and it's 36 volts. So it is a 36 volt printer. Very odd. Right, that's some bits. Now, to get this out, we do have to continue to be careful, because it's still connected to many things. So they're all load cells on the side. More load cells everywhere. This is the weirdest bonkers setup. It might be really good. I'm not really sure. This is not. This is forcing loads of terminals onto a very small thing where it doesn't really fit. So these are 3 load cells. Hopefully, I mean, it must matter. Does it matter? I'm guessing it doesn't matter because it doesn't look like they've coordinated which one goes where. So that's that, and then there's loads of wires for the heaters. Woohoo! Try not to drop it, Adam. You know what camera's probably better right now? That one up there. Boom. There we go. Now you can see what I see. See, that's kind of blurry, isn't it? I think it's digital zooming, so it's just kind of cropping out the picture that you can't see. So it's a 36 volt, 10 amp power supply. Which will, of course, contribute to motor performance. I'm not sure what the flip is going on with this bed. Where are these wires going? One's going over here, so that's an SSR. They're going from one side of the SSR to the other side of the SSR. What the actual lipsticks is going on? I've never seen that before. Then there's this kind of sensory cable thing. Oh, this is so confused. So this, I'm sure here, is an SSR. Yes, it's labeled SSR, solid state relay. What I'm confused about is why this wire comes out of this side into this side. Normally you have this side is low voltage, and that controls whether the switch is on or not. And then this side is the switched high voltage side. Makes no sense. That's the mains coming in here. Oh my god. I'm not sure I probably even want to open this. That is electrical tape around a mains connection. Oh my days. So that appears to be what FLsun thinks is acceptable. We'll just solder that and bang some electrical tape. That'll do. Holy shit. So blue is just blue and black, because why not just make 2 wires 1 wire? That sounds like fun. And we're connected to both sides of the SSR, because why the flip not? So this was live. They got live going to both sides. What the actual? Is it a 2 output SSR? B1, P2, solid state relay input. I have no idea. I need to look up this SSR because this makes no flipping sense. Low voltage doesn't go anywhere near this. So neither of these sides are low voltage. This one goes out to the bed. So these two go out to the bed, and this comes from, so this is live input and this is output mains. My guess is this is not a SSR that we've typically seen before. And it's a 2 switch SSR. I think what is happening is this controls the switching, and these are 2 outputs. So this can change whether this is on or whether this is on. This is the mains coming in, and this is 2 different mains on 2 different colors, even matching the same input color, that controls the 2 different heating zones on the bed. What the F? I mean, oh god, I just hate when wire coloring doesn't make any sense. That is what's happening though. I'm fairly confident of that. I could be completely wrong, to be honest, but from the wiring that I see, it is the only thing that makes sense at the moment. No, this is still not coming out. Oh, we've got... Oh, that's 2 thermistors. Maybe this is why people don't want to send me printers anymore. Right, let's take this out. So there's the bed. It is a dual heating zone bed. It is a mains powered bed. It appears to use a 2-switching SSR. It has 3 legs, each with a load cell on. It has insulation for some of the bed. Insulation for some of the bed, but not for this bit over here for some reason. It has 500,000 wires coming in and out of the bed, of which it's not entirely clear what each one of them does. So the 2 small ones, these are the 2 thermistors, presumably for the inner and outer zones. Does that make any difference when you've got an aluminium bed that just conducts the heat across the bed anyway? Who knows? We then have the input, which is just 2 wires jankily soldered together and covered in electrical tape, because that seems safe. And then we got... Oh no, this is the neutral. This is the live. This is the neutral. So this is sort of the output, sort of the out. Electrical out is mains neutral, and this is mains live. One for the inner and one for the outer, but I don't know which way round. Oh, blimey, Charlie. What do I like about it? I like load cell beds. They're kind of interesting. Because it's a good way to kind of probe the bed. I don't know if they're actually using that method. I guess they are. They've got sensors on the hot end up here as well. So I think they've just put all the sensors on and we'll work out how to use them later. Yeah. It's a bit weird. Typical kind of silicon heater mat though. And it has these stops at the back, which is quite handy for putting the top surface back on. Back on. Bacon. My biggest personal issue. Well, let's not talk personal issues. Let's talk technical issues. Well, Z offset just doesn't seem to work properly, which is like fundamentally critical to having a printer work well. Their flow rate claims are absolutely absurd. The maintenance of the hot end assembly is diabolical. The weight seems overkill. Moving it anywhere is almost impossible. Getting it into your house is almost impossible. Very, very difficult. It's a very impractically large size. I'm not sure how many of the things it claims to do, it can actually do well. But apart from that, it's fine. I'm not recommending this printer. I'm not doing a live stream to promote and try and sell it. That is not the point of this. The point is, I think they're interesting. The hardware is interesting, and I want to see it further. But I would not recommend buying this machine. I think it's rather a mess. The electronics are certainly showing that to me at the moment. I'm just going to try and get this other camera to turn on. See if we can revive it. Hang on a second. We've got to work out which part of this printer we're going to tear down next. These like support beams, maybe they should stay in for as long as possible. The electronics, oh, it looks like they might all be on like a tray. We've got a whole bunch of this electronic stuff down below as well. This huge like ribbon wire, it's got like 20 wires in it. It's a fairly critical connection. That's another panel. That's a huge cast piece. How are these screwed on then? Oh, there is some screws down there. Take those out. I'm starting to think this attaches the top to the bottom. Yes, this is going to be these at the side, I think. Dedaco, hello. Seems like the world is waking up to the madness. My madness. There's just screws that have just not been put in. You can see... No, you can't. Let's get this around here. Maybe... Oh, you can... It's just kind of a light issue. Yeah, as you can see here. You see this bit? Where there's two fingers going up here and here. Here and here. Where there's little holes at the top. It looks like there's meant to be screws there. And it looks like they're supposed to go through this because there's holes in this too. But there are no screws. They've just not put those screws in. We don't need screws where we're going. Even these molded plastic pieces are just huge. Huge printer is huge. Who'd have thought? Ooh, there we go. We've got screen number 3 back. There's like these... Oh, they're for those. Yes, they go over these screws here. That makes sense. I mean, in fairness, where they've not put screws in, they may have some justification that they've decided they don't need them or something. That the printer is sufficiently good without them. I don't know. It always feels odd to have screw holes with no screws in them. It should be a bit heavier, a bit lighter. Oh my god! It still weighs more than most printers. But but it is sort of handleable now. This seems fairly reasonable of all the parts. Probably one of the best, actually. Covered terminals, they don't slide off. They're labelled, they're not labelled in English, but it is what it is. I need a better view. How can we get better view? Move this. The printer was already screwed, they decided no need to add more. How's it going? I'm coming halfway through. I think they were trying to aim at the semi-professional user, but appears to be all fur coat. There are issues, for sure. The hardware continues to be fairly impressive, if a little overweight for a consumer market. Maneuverability in a house is an important factor which will get overlooked when you're trying to just make everything as strong and massive as possible. I thought the S1's madness was mainly contained in the firmware. There is lots of extra madness in the firmware. The offset is not working. I've forgotten all the stuff that I mentioned about this printer because it was so much, and which is why I ended up not making a review. It just wasn't worth the airtime. So I thought I'd do this instead. I don't think it helped the Prusa out of nowhere told them how to make a Delta. Yeah, I mean, obviously there's a big price difference between the two, but I mean, I've not tested the Prusa's HT90 thing. It's probably much better based on their reputation. One would hope so. It wouldn't be very difficult. But I think the price for the hardware is good, but like the printer doesn't really print. Prusa didn't build their Delta, they bought a company who makes Deltas. Well, yeah, they bought, what was it called, Trilab? I spoke to them at shows quite a few times, actually. But I think they've developed a new printer based on their expertise. Yeah, it's 9K, exactly, and it's high temperature, like it's completely different class of machine, really, the Prusa one. I'd be kind of surprised if FLsun haven't bought one and they're trying to copy it. Or trying to copy specific technology out of it. I think that's what many people do. I mean, this bundle of wires is an absolute mess. They've put the connector so close to the edge of the printer that there's barely space for the cables to go in. They have no software. That printer is not worth 1,400. Well, they do have software. They've got a slicer. It's just pants. It's not just Clipper. It is Clipper, but it's not just Clipper. If it was just Clipper, it would be fine. But it's not just Clipper. It's Clipper that we've modified a little bit and locked it out so you can't remote into it. We've added weird dinky shit that doesn't work properly. And ta-da! Look, we've got our own firmware. Yeah, I mean, any printer you buy should work. I mean, I don't think I'm ever going to argue that it's fine that you've been given a printer that doesn't work because you didn't spend money. If someone's going to charge you $200 for a printer, it still needs to work. I mean, they've put some effort into cable management, which is nice, but a bit more effort probably would go a long way. They've also got this huge, dangerous-looking bank of capacitors, which I need to avoid touching because I have no idea how charged they are. I think that's how they do their power loss detection recovery thing, whatever it is. Like, you just charge up a bunch of capacitors, they have loads of energy in them, and when there's no more power, you use the energy in the capacitors to, to shut everything down. But in this case, there is a crazy, crazy number of them. And they're probably charged, I guess. I don't know. But I think we should be careful, because a capacitor of that size will probably have lots of juice. Which is why I will say, do not do this. Yes, and they're all just linked in series. This might look a bit stupid, but I'm just trying to short all the terminals of the capacitors to themselves, hopefully. Maybe it was not to themselves, maybe it was to the adjacent one. It looks like there's no charge in them though. So there was originally USB ports on this. Oh no, yes, no, 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 don't know. I mean, yes, there was USB ports. I'm not sure what they would have been doing. Right in there. Now we have this weird SSR. Which is an SSR, but not as you know it. Still in Chinese on the side. TYRSHI looks like the brand. really not that impressed with the camera on this phone. It looks good in like video mode. As soon as you get it into camera mode, it just starts making stupid decisions. Yeah, so we've got looked like A1, A2, B1, B2, but instead of input one side, output the other, it looks like it's controlled by this stuff in the middle, which is what I said earlier. It's an SSR-SK10DA. SSR SK10DA. First link, AliExpress. Single phase dual channel SSR. Dual channel DC control, dual channel AC with high strength screws. 10 amp. Control voltage 3 to 32 volts. So presumably they're down rating that because it's a 36 volt printer. Does the video look really dark now? God, these... Is it just gone dark or is it just me? This is much brighter, isn't it? That looks good. This just doesn't. It just looks a bit naff. Ooh. Auto exposure just exposes quite dark. Auto white balance. Sorry, I shouldn't be fiddling with this now. That looks reasonably nice compared to that. Right, sorry. Sorry for the flashbang. That was not intentional. We don't have much in the bottom now. We only have this, and that is screwed in from the underside by the looks of it. And so we need to move on to the next part. Good night, Prince Frank. Yes, don't forget to hit the like button if you haven't already. Don't forget to check out vector3d.shop. We're not finished yet. I just like to talk about my own things. In fact, I don't talk about my own things very much. So there we go. Anyway, ads will run shortly for some viewers. Apparently, that's what it says. I know nobody likes ads, but it's part of life. Yes, we've got to get this stuff down from the top. How are we going to do this? Holy bananas, why does it still weigh so much? Well, I know, but like... Oh my god, it's huge. It's so big, you cannot comprehend how big this is on camera. It's just flipping huge. What if I zoom out here? No, wrong one. Wrong one. No, come on. There we go. It's so huge. Oh, it's a bit wonky, this camera, sorry. We get wonky view for a bit. I've got to work out how to take this bit off. Yeah, it is all the stuff at the sides. How... Okay, I think I have to unplug all the things first. Which is actually not that many things. No. Oh, this is going to be annoying. Right. I think we just have to take all the electronics out and then remove the panel. Go here. Ta-da! Right. A bit. Oh, I keep controlling the wrong one. A bit of it. Thank you. A bit of it. There we go. They've even put glue on a USB-C cable. Snips. Snip, snip, snip. Snippy here. Snippy here. So they've got these huge cables for the stepper motors because they're closed loop. Well, they've got like a closed loop board on them. So I don't know what the signals are that they're sending to each one, but presumably there's some sort of send and receive in there. I don't really know how it works because I don't know what they're using. It's just this horrible goop. This is like the worst goop of all the goops. The one Creality uses is pretty nasty, but at least when you pull it, it comes off. This one just breaks. So that's the one that goes to the spool holder and heater what's it doodah. This is another motor cable. Huge blooming thing. Huge thing. This is a USB-C cable which goes all the way to the bottom of the machine. So just snip that. Oh, that doesn't even go through the hole. This cable comes in here and goes back down here. So that goes to the Toolhead. Oh, that's one of the other USB-C cables. Oh my goodness. How am I going to deal with that? Can I take it out? Another fat bundle of cable. Yeah, so this is the 3 USBs. So one of the USB-Cs is the camera. So it's actually just USB 2. One of them connects to the main board. And one of them connects to the toolhead. They both have ferrite cores all over the shop. But we can't take that out of there without that coming out of there. Oh, this is just a pain. Why does it go up through this hole and back down through that one? It is silly. Another capacitor on there. This is the control board for this massive CPAP fan. Centrifugal blow. That's an absolute chunky boy of a fan. So there is one stepper driver of the traditional type on this board, and I assume that will be for the extruder. But that's driven by USB-C? What the hell is that USB-C? Oh, maybe it's the sensory thing. Whoopsie daisy. There's like a lasery sensor thing in the hot end that apparently scans the bed, allegedly. But yeah, I don't know if that's USB-C or what. What was I going to do? Unplug this. So, tube out. What's this one here? That's going two ways. Probably LEDs would be my guess. It's coming down here. Yes, that is LEDs. This green wire here that plugs in here, LEDs. The thought of reassembling this printer has just sort of crossed my mind. And I'm not sure I want to. It's a lot of work just to disassemble it. Normally disassembly is easy. I think one of the reasons it doesn't vibrate that much. I was thinking that one of the reasons for the noise could be that this fan is attached to what is essentially a drum. So that's like a rubber gasket that's on there. Not sure what that does. Oh, that's been attacked, isn't it? That goes to this. That's your serious fan. Maybe we can have a look at this stuff a little bit closer in a minute, after I've removed it all from this. So this is this like hash of rainbow coloured cables is the massive, thick, chunky boy that runs down to the hot end. Okay. Again, not very much space to actually plug it in. Everything's very restricted. Still don't understand how this load cell is held in. It makes no sense. There's no screws. Oh no, there is. These two. They've put. Oh. So you basically have to take out the entire motherboard in order to remove the load cell. And the screw is right in front of where the main cable comes in. So there we go. That's the load cell carrier. A 10 kg load cell. Seems a bit much for a 1 kilo spool, but who am I to judge? What the fuck do I know? That's your single stepper driver, covered in glue. TMC 2160A. I think it's an A or a K, but it definitely says, oh, TWC? It's a something. It's the control board. Let's unscrew these. Have a look at that in a second. Poke these back through here. Like, because they've put one connector for these two LEDs, it goes through this hole and it goes through this hole. So I can't put it back through that one or through that one. I have to get the LEDs and feed them all the way back up through here. It's a nightmare. It's a waking nightmare. I think this big fat cable is the one that goes all the way back down to the bottom of the printer. The other thing we need to take out here is this, but I think it's, yes, it's extra tiny. Maybe this. They've got some weird spacer. Looks like it's made of cardboard or something. Please don't be made of cardboard. There's more underneath. Presumably they're there to isolate it for some reason. This is a huge bracket that's just here to hold this cable up the top and stop the movement of the tool head pulling it out. So that's the tool head cable through that hole. That's the annoying one, and that's the other annoying one. Now, we're going to deal with these cables. Can't get those past there because of this. We need a 2mm ball head, which I don't think we have out yet. 2.5. Mil ball head. I have to take off this support bracket. More screws for that. A lot of these screws are identical. I put them in different trays, but ooh. Did I really undo the screws on the other side? I don't think I did. I think there just weren't any screws on that. Maybe I already undid them? Well, anyway, that's the FLsun logo with, excuse me, filament sensor on the back. This piece is actually plastic. One of the few plastic pieces. Then we have to deal with all these USB cables which are all twisted. Right, there we go. Just some really long USB-C cables. Plonk that down there. Feed this one through here. Can't feed it through because of this stinking thing on the end. I'm guessing they put these ferrite choke cores, ferrite cores, whatever they are, on the end to improve signal integrity, because maybe there was an issue with it. Oh, do I have to take it off again to get through there? Probably should have checked which number does what. Oops. This is why we have a video recording. So this is number 1 and this is the tool head. Right, that's going back in there. Right. Just about space. This is a coffee table. Do I lift it up? I want to take this tray out first. Oh, I need to get the LEDs out. Oh my goodness. Let's lift it up. Easier said than done. Right, let's have a closer look at some of these doohickeys which I've collected. Camera controller, Dune, over here. Slightly better colour, maybe a little bit. So we'll get rid of the wires. I'm sure you're not that interested in those. So this is the load cell. So under here there'll be one strain gauge here probably, and one strain gauge here maybe, or it might just be one up here, one down here. Can't remember exactly the configuration. Anyway, there's load cells, strain gauges rather, and they detect the elongation of the material that they're attached to, or their own elongation basically, and that converts via some maths to a weight, to a mass. So yes, that attaches up there. The spool holder thing was on here. So when that gets pushed down, that detects the weight. That's that thing. This is a fan. This is a very speedy boy fan. Looks like we can open it up. So seeing as we probably shouldn't, we definitely will. Ah, nice. They've used some PTFE tape, Teflon tape rather, to fill the gap so the thing fits on. Quality. Goes in there. Maybe this. Might not be a good idea, but we're going to do it anyway. I'm doing this so that you don't have to, so I might as well go over the top. Interesting. So why does that not come off? I'm thinking he could just rebuild it back with off-the-shelf mainboard and other parts so he could run machine on clipper. That was kind of my initial thought, but I don't know what I want to do yet. Das the base of the fan. I'm not happy with the quality of these cameras. They are not great for doing... Oh golly, that's fast. Yeah, even like it is really zoomed in. I could just do this. Yeah, I suppose it's not too bad. It's just me being fussy. I'm trying to just take off the top of this as well. But for some reason, it no want to budge. I think it's been glued as well. Screwed and glued. completely just like filled the gap. I don't know how these were made, but obviously not very well if they don't fit this. Oh, does need to fit. Not great, I suppose. Yeah, I think it was a bit glued. So I believe this is what you call the impeller. So it sucks air into that middle bit, because obviously that's the bit that goes on the top. So that is your input right in the center. And then it sucks it through those vents and pushes it out through those edge holes into the chamber, where can you see the way it's spinnies like this, push gradually more air, and it all shoots out here. And this is the PCB. Obviously the main controller is this bit. We'll look at that now. Can we get that all out? No, it doesn't come out really very easily. Serious metal housing though. First one I've seen in a metal housing. Yeah, full metal base. And then that's your top. So let's put those screws to one side. Those screws with that, and then all this stuff go in here. This was the fan for the controller. Just a 4010 fan, nothing exciting whatsoever. Just a wire, hose clip for the tube, air feeding tube. This is the main control board, but there's not much on it. It looks like all the processing, if you like, for the stepper motors is done on that control board up there. So it does the closed loop feedback, whatever. Got a button, got one stepper driver for presumably the E motor, which goes out here. SD card slot, probably for flashing firmware or whatnot in the factory. This was power something, maybe power just to the board, that's probably what that is. And then these were just big ribbon cables. This is motors, 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 motors. That's down to the base of the printer, I think. Maybe that one to the base of the printer, I'm not sure. And then we have this rinky dinky tiny little thing, which has these weird screws with these weird little isolators on it. With a very weird cable connection. Blimey. What the F? They couldn't be bothered to use the connectors on there, so they just soldered some shit to the bottom. Perfectly good connectors. Soldered to the bottom. Oh dear. Why do it properly when you can just do this? Can't see any good reason. Right. We march on. Shoot, it's 2 o'clock already. Holy bananas. What time did we start? Literally hours ago. Right, I have less than an hour. There's a filter on top. A bit. There's a bit of a filter. It's not really a filter. It's just a mesh in the steel panel. So this is the printer we have left. Oh, how am I going to do all of this in an hour? Shh. It sticks. Right. That's the wire for LEDs. I don't want to cut corners, and I think I've got way more than an hour's worth here. Is it best to resume later? Or do we power on and miss my meeting? What's the best plan? Do we have a break and carry on this afternoon for a couple more hours? I don't know. This has taken much longer than I thought. That's the tube. The tube for the tube things. I'm going to need another bucket. Something smells funky. It's got that funk. Right, let's get to the top. We need to get this panel out. Stepper drivers. So LEDs. Let's go. Bosh. Bosh. Cover panels for the LEDs. Kind of good because they give you a nicer diffused finish. Wires for the LEDs. Presumably they're all set up for 36 volts. And then we can just pull that wire up here and that will come out the top. Nice. And then that can come out the top here. Nice. And then that's the split wire for the LEDs. Done. Next. Bunch of screws to take this top panel out. This is another panel that weighs a ton. In a surprise to literally nobody. It's massive overkill. Fuck me. That's one heavy slab of steel. 1.45 kilos. So nearly 1.5 kilos. Just this one piece. So much weight. Such weight. Much heavy. Very printer. Now, we need to somehow attack this kinematic system. Let's get these panels off first. They've used some kind of spacers, because presumably the sheet metal parts don't fit the gap precisely, and they need to make sure that even though they're trying to support, they don't want to pull the beams inwards, because that'll make a hash of everything. Probably a pretty good reason not to have them at all, really. Ooh. They're not going to be easy to put back in. Oh, I can see from the amount of scratching on the post that they were not easy to install. Each of those is another 550 grams, half a kilo. Another half a kilo. The sort of holes, those are the things where the handles attach to. So they've got to be reasonably strong, as you're going to be picking up the rest of the printer from those. Although, because it's a triangle shape and they're only on two sides, they tend to never really be in the right place for actually lifting it. But apart from that, in theory, those are where you could lift it from. We'll leave that. What is next? What is next? What is next? What is next? These fancy stepper motor doublés, how do we get those off? Right, I think this goes up to the top. I'm probably not going to disassemble all three legs because it's a bit unnecessary. We can learn, I think, everything we want to learn from just one. This way. So this is the tensioner, and I think it's going to be easier to deal with if we undo these screws. That made no difference. Oh, no, it did. There's some banging screws, springs, I mean. Now, as soon as you say the word spring, you have to put on safety glasses. Springs pinging out is extra danger. I don't know how much about closed loop stepper drivers. Do they not need drivers like normal steppers, or are the drivers on the individual PCBs? Oh no, yes, there will. Oh, I mean, steppers don't need stepper drivers. Stepper drivers is just a way of driving a stepper motor. You can use, I think it's like an H-bridge setup, which is what Bamboo uses. They don't have individual stepper drivers. So that's gone loose. Loosey-goosey. Take the belt off of here. Dust the belt, dust belt. That's 3. Hopefully we can get this off without me landing a stepper motor on my head. It'd be mildly inconvenient. Oh, there we go. Oh, right. Holy shoot. Right. Let's get that screw over there. So for starters, you've got this whopping great belt, which is huge. Then you've got this stepper motor, which is actually not as big as I thought. You've got this absolutely humongous pulley. Oh, sorry. Let's sort some camera angles out. Oh, wrong one. Camera 2. Zoom. The assembly weighs 500 grams, half a kilo. So, oh shoot. This is a huge pulley. Pretty big. Directly attached to the stepper motor. It has an extra large shaft. Normally NEMA 17 are 5mm or 6mm shaft. What is it? 5? I think it's 5mm. This looks like an 8mm shaft, which is normally NEMA 17, I think. And then this is the whole... So this is the end stop. And I think this is like a hard stop with a homing, maybe? I don't know. It looks like something where the carriage will hit up against to help with homing something, but I also could be very wrong because you also have this optical sensor, which would be the homing. So it looks like they don't have a traditional stepper driver. They've done the bamboo route, I think, because that's what this arrangement here is. That's how they drive the separate coils, because this is the 4 wires going out to the stepper motor, and this is to the end stop. So these 4, that's where the motor is going out. So these will be controlling that. These probably relate to each 4 of these. So don't know how it works, but it kind of does. Question is, does it have some optical rotationary sensor thing? It must do. Oh, they have their own stepper. It's called FLsun stepper motor. So you can see the back of the stepper motor there, the huge shaft on it. If I can get it aligned. Some focus, please. Focus, please. And then this is what the board looks like. And the back of the board. One of the chips on the back has got to be reading the rotational position of the stepper motor, because that's the whole point of closed loop. Is that, so open loop is when it's just end to end. So you have a, in this case, the microcomputer, single board computer decides like what needs to happen. It sends the command to the control board sends a command to the motor, and normally the motor does it, and it just assumes that all of that happens. So you have from the input all the way to the output, and that's it, done. Whereas closed loop, it means it kind of closes that from a straight line. You have something that comes from the end back to the beginning to tell it where it actually is. And you don't need to measure the head position because there's no slippage between, because it's a toothed belt. The only place where you have potential slippage is at the motor. So you just have to make sure that when you tell it to move a set amount, that it moves set amount. So something here, we'll be reading that, but I don't know what. We shall take us some pictures and share them later. Quite interesting. I expected the stepper motor to be longer. I mean, I sort of looked in, you can see they're quite large, but there are longer stepper motors than that. But they have very large pulleys. And again, obviously this thing weighs an absolute ton. This is not folded steel, this is like, it looks like, I don't know, because they've got tabs which stick out here. This is die cast. Holy shit. So this is a whole die cast bracket specifically for this that weighs half a kilo with the motor. Absolutely bonkers. Kind of cool, kind of bonkers. I'm not sure closed loop is really needed for 3D printers. If you set up your profile correctly, I mean, it's, I don't know. In my mind, partly, if you set up your profile correctly, right, you know that your motor is not going to skip because you're not pushing an acceleration that's going to make it skip. The only thing that would then make it skip is having some part of the print like curl up in a way that it forces the head into it and causes something to skip. At that point, your print is already ruined, so it doesn't matter if the tool head suddenly manages to crack, because the print is already rubbish, probably. So it doesn't make a difference. Technically, does it make a difference in practice? Probably not that much. Do we want it anyway? Probably. Right. So that's tool belt. Wow, it's even bigger than, oh, that's 2.5. 3 pull, 3 straight. These, I'm almost certain, are custom die cast blocks. Holy balls there. These are Loctited in, I'm pretty sure, because they're very difficult to get out. Oh, they don't seem to be Loctited. I don't know why they were so tight. That doesn't sound very well lubricated. Sounds like it's lubricated. It looks like it's lubricated on the outside, but they forgot to put lubricant on the inside, which is like you can hear the bearings rattling around. I don't know, maybe it's alright. Doesn't seem perfect to me, but what the fuck do I know? I don't want to disassemble these because these can be a nightmare to get back correctly. I've already disassembled the tool head Did I share pictures? Oh, I hate having less time than I wanted. What's the next thing we can do? I'm getting a bit hungry as well. This is the other problem. What can we disconnect to get to? I kind of want to take one of the legs off and the base off so I can see what they weigh. And then we're sort of there, I think, apart from the hot end and extruder, which is in itself a problem. Mm. Let's lay it down. I mean, this empty frame alone is heavy. Take the bottom panel off. What can you see? Nothing. I don't understand how I managed to be so slow. I feel like the first 3 hours went by insanely fast. I must have been very, very slow to actually do anything. I just don't really notice, I suppose. I just sort of do things. As we know, that's going to weigh a lot. That's the power supply attached to the base. Bunch more screws for that. Into another tray. Right. 12 screws, and we should be able to get this ridiculous base off. At this point, I think it might be cast steel rather than cast aluminium. Just because of the weight is just... I don't know how they can make the printer weigh that much if it's not. 11. One more. This is the bit where you find out the base is like glued on or something ridiculous. Now, it could sag a bit because this top part won't be supported. Oh, that comes off. That comes off. And this comes off. One single huge piece. This thing must cost a fortune. How the hell did they produce this? Well, I know like how, but like, holy crap. Look at the size of this single cast piece. It's actually mind-blowing. Look at the flipping size of it. It's fucking huge. Crikey, right. Crikey. I should weigh it, shouldn't I? What does it weigh? Not going to be very easy to weigh, I don't think, this. The trouble is my scaling goes up to 3 kilos, so it's meant to be for coffee. For obvious reasons, you don't normally have 3 kilos of coffee. This is right on the limit. 2.9 kilos, basically. Absolutely huge. Hello, Spectre. Now, the problem is if I take the top one off, the carriage can slide off of there, so I really don't want to do that. Have I done enough, or do I need to do more? Does this count as disassembled? I feel like I've just been time constrained. Time has been my enemy today. I'm not satisfied that it's done, so I think I need to do a little bit more, but I have run out of time. So I might put up a part 2 live stream and we'll try and do another hour and a bit from maybe like 3:30 onwards. Maybe 4:30. Maybe 4 o'clock. 4 o'clock till 5:30 or something. Another hour and a half, and we'll try and do the hot end extruder, a bit more the carriages, that kind of stuff. I wanted to do it all in one, but sometimes it just takes too long. So with that, I think we have to leave it there. And as I said, we'll resume again later. Oh, it's exhausting doing this. Oh, so much work. Oh. How long have we actually been going? It's not totally clear. Oh, 2 hours, 45 minutes. Not as long as I thought. Somebody said over 3 hours. 3 hours or so ago. No, so it's just past 2.5 hours. It's not too bad. 2 hours, 45. I must have been a little bit late. Yeah, 11:45 is when I started, wasn't it? Should have started earlier. Anyway, that's what we've got for today. I'll try and do a little bit more later this afternoon, squeeze a bit more in. Try not to fall asleep in the process. Thanks everyone for watching, and I shall see you again soon. Goodbye for now.